One of these machines needs a camera system just to see the road in front of it. Another pulls loads that outweigh entire buildings. And the one at number 1 holds a Guinness World Record for moving close to £1 million down a public road. Number 10. Peterbilt 389 runtime. Every list of extreme machines has to start somewhere, and the Peterbilt 389 is where the scale conversation begins on North American highways. This is the truck that defined what a big rig is supposed to look like. An extended hood stretching so far forward it takes up more road than most standard cars, dual chrome exhaust stacks rising like industrial smokestacks, and a squared grille that makes every vehicle in the adjacent lane feel small. The 389 runs a Cummins IS-15 pushing 600 horsepower through an 18-speed transmission. It hauls 80,000-pound freight loads across continent-spanning routes, including the steep grades of the Rocky Mountains. And it does it with a style that no modern aerodynamic truck can replicate. Independent owner-operators built careers around this machine because it combines genuine capability with a road presence that announces itself from a quarter-mile away. Impressive by any highway standard. But on this list, it is where the numbers start, not where they end. Number 9. Kenworth K200 runtime. Australia's highway regulations create an engineering paradox that the Kenworth K200 was specifically built to solve. The law caps total vehicle length. The loads keep getting heavier and longer. The solution was to eliminate the front hood entirely and position the cab directly on top of the engine. A cab-over design that compresses the tractor's footprint dramatically while freeing maximum legal length for trailers behind it. When the K200 connects to triple or quadruple trailer road train configurations, the combined system stretches over 50 meters across the outback highway. The driver sits elevated above the engine with a panoramic view of red dirt road disappearing into a horizon that barely changes for hours. Behind them, 200,000 pounds of cargo generates momentum that requires constant management. Every steering input must account for the delayed response of multiple trailers following in sequence. The K200 is not impressive because of its size. It is impressive because of the system it controls. Number 8. Kenworth T909 runtime. In the Australian outback, the enemy of a heavy haul operation is not the distance or the terrain. It is heat. Temperatures regularly push past 50 degrees Celsius across stretches of desert where the nearest service facility can be hundreds of kilometers away. When an engine overheats in those conditions, the mission does not pause. It ends entirely. The Kenworth T909 was engineered around this single brutal reality. Behind its towering front grille sits one of the most aggressively over-engineered cooling systems ever fitted to a road vehicle. Expanded radiator surface area, reinforced airflow architecture, and thermal management systems built to keep the engine operating at stable temperature during continuous high-load desert runs. Pulling 260,000-pound road trains across barren, unpaved outback routes, the T909 functions less like a transport vehicle and more like a mobile industrial power station designed to maintain performance where the environment is actively trying to destroy the machine. Heat is not a variable it manages. It is a variable it was built to dominate. Number 7. Mack Superliner runtime. Past a certain point of torque output, the truck itself becomes the engineering problem. The Mack Superliner operates at exactly this threshold, a machine where the force generated by the engine is large enough to begin physically twisting the chassis it is mounted in if the frame is not reinforced to absorb it. Under the Superliner's bold squared hood sits a 16-litre MP10 engine producing 685 horsepower. Under heavy haul conditions, the torque transfers through the drivetrain into the chassis and places sustained stress on every structural joint in the vehicle. Massively reinforced frame rails handle what conventional steel construction simply cannot. The Mack Titan, direct sibling to the Superliner, set a Guinness World Record in 2006 by pulling a road train stretching close to 1 full mile. The Superliner carries that bloodline in a machine built to survive the forces its own engine creates. 685 horses producing enough torque to destroy the truck containing them if the engineers had not planned for it. Number 6. Hayes HDX runtime. Every truck on this list so far has been built around the challenge of moving weight forward. The Hayes HDX exists because of a completely different and far more dangerous problem: controlling weight on the way down. On the steep logging roads of British Columbia, the grades hit 18 to 20%. The surface is mud, compacted dirt, gravel, and ice depending on the season. Behind the driver are raw timber logs the size of school buses, generating hundreds of thousands of pounds of momentum aimed directly at the edge of the road. Standard friction brakes would overheat and fail within minutes of a single descent under these conditions. The HDX uses engine retarders to convert kinetic energy into controlled mechanical drag, reducing dependence on friction braking entirely. The driver simultaneously manages the retarder system, manually activates water cooling on the brake components to prevent thermal failure, and maintains vehicle stability across terrain where traction disappears without warning. It is the most dangerous regular driving assignment on this entire list. The machine is the only reason it is survivable. Number 5. Kenworth C509 runtime. When the road stops existing, the Kenworth C509 keeps moving. Built specifically for remote Australian mining operations where paved surfaces end long before the cargo reaches its destination, the C509 was designed for terrain that would destroy any conventional heavy transport vehicle within the first kilometre. Its unusually tall ride height protects critical drivetrain components while navigating deep desert ruts and river crossings. Hub reduction drive axles multiply torque directly at each wheel end, allowing the machine to drag mining excavators and industrial equipment weighing over 400,000 pounds across loose sand at controlled low speeds. The C509 does not accelerate to its destination. It grinds toward it, gear by gear, axle by axle, in a methodical mechanical battle against terrain that offers no assistance and no margin for error. When recovery options are measured in hours and the nearest hard surface is dozens of kilometers away, this machine is the only option that works. Number 4. Mercedes-Benz Actros 4163 Svelte runtime. Getting 500,000 pounds to begin moving from a complete standstill destroys conventional clutch systems in seconds. The friction required to initiate that movement generates heat faster than any standard mechanical interface can handle. The Mercedes-Benz Actros Svelte solved this by replacing friction with fluid, a turbo retarder clutch system that uses fluid dynamics to transmit torque smoothly under extreme load conditions, allowing the truck to begin moving immense weight gradually without the destructive shock loads that shatter conventional driveline components. The result is a machine that can pull 500,000 pounds through narrow historic European village streets at walking pace, 2 miles per hour, calculating every centimetre while squeezing wind turbine blades and power plant components through brick roundabouts with almost no clearance. 625 horsepower, making the physically improbable look routine. The technology is invisible in operation. What the driver feels is enormous weight beginning to move without violence, as if the laws of physics have been politely negotiated rather than forced. Number 3. Volvo FH16 750 runtime. 750 horsepower. 2,600 pound-feet of torque. For multiple consecutive years, the Volvo FH16 750 was the most powerful production truck on the planet. The number that explains what it can actually do is not the horsepower figure though. It is this. From a complete standstill on a steep snow-covered mountain, incline the FH16 750 can initiate movement with 650,000 pounds loaded behind it. That is not a press release claim. It is a documented operational capability proved on real frozen mountain roads. Volvo's ultra-low crawler gears distribute torque across multiple driven axles and control wheel spin on surfaces where grip is minimal and a single moment of wheel spin ends forward progress entirely. The engineering that makes this possible is not dramatic from the outside. From inside the cab it is, pressing the accelerator on a Norwegian mountain pass in winter with an electrical transformer on the trailer and feeling 750 horses find grip on ice and drag the impossible weight uphill. Absolute engineering witchcraft. Number 2. Scania S770 V8 runtime. While the rest of the industry chased efficiency through smaller engines and aggressive turbocharging, the Scania S770 V8 went the other direction entirely. Its 16.4-litre V8 produces 770 horsepower and 2,700 pound-feet of torque, and it delivers that output with a consistency across extended operating ranges that high-boost, smaller displacement engines simply cannot replicate under sustained heavy load. The V8 configuration is built for endurance, not just peak performance. When pulling massive industrial loads across long routes where load resistance never decreases for hours at a time, an engine that maintains stable output rather than one that peaks brilliantly and then struggles is what the job actually requires. The Scania S770 is also the most characterful machine on this list. Its deep, guttural startup sound is something experienced drivers describe as the only confirmation they need that the machine is ready. At this level of output, only one class of machine goes further, and that machine had to be built from scratch. Number 1. Nicolas Tractomas runtime. There is a boundary past which the concept of a truck no longer applies. The Nicolas Tractomas was built specifically for what exists beyond that boundary, a custom-engineered French machine that officially holds the Guinness World Record as the largest civil road-going tractor ever constructed. Its 27-litre Caterpillar V12 engine normally lives inside giant mining dump trucks. Here it sits inside a road vehicle producing 1,000 continuous horsepower through a 10-wheel drive system. The hood is so tall the operator requires high-definition camera systems to see the road directly below the front of the vehicle. The machine was built for one purpose, moving loads approaching 1 million pounds across desert landscapes in South Africa and Australia. Not freight containers, not mining equipment, entire industrial structures, refinery components, energy infrastructure the size of buildings. At full operational load, the Tractomas does not drive to a destination. It moves toward one, measured in meters per minute rather than miles per hour. The 10-wheel drive system grinding into tarmac with a force that is physically felt by everyone standing nearby. This is the outer edge of what terrestrial transport engineering can produce. A machine that does not simply carry weight, it makes movement possible in situations where physics itself argues against the idea. 10 machines. A highway icon built for swagger and stamina. A cabover that controls 50 meters of road train. A desert survivor that never overheats. A logging truck that fights gravity with water cooling. A mining crawler that goes where roads do not exist. A precision European hauler that moves 500,000 pounds at walking pace. A Swedish mountain climber that defies ice. A V8 legend built for endurance. And a Guinness World Record holder that moves close to 1 million pounds down a public road. Drop a comment telling us which one you would want a seat in. Check the end screen for more extreme engineering waiting for you right now.